Now this is a mains testing screwdriver, and there's a couple of major issues with this, but first I'll just quickly show you how they work. Now these are very cheap and pretty common, so I think they're pretty standard for a DIY to own and in fairly wide usage. Now the way these screwdrivers work is you just take it, stick it into the terminal and put your finger on the end here. You can see just in the screwdriver there is a light that lights up when I touch the end. I'll just turn the light off so it can be seen a bit more brightly. But this is the first major problem with these, is that it's very difficult to see if it's bright or if you're outside. See there, with the light off it's a bit easier to see, and when I touch the end, when I stick my finger on the end, it lights up. But when the end is just in the terminal with my finger not on the end, it doesn't light up. You need your finger on the end to light up. This brings me on to the next issue of why these are so dangerous. It's how they work. So you need to have a complete circuit to light up the light in here. And when you've only got a single prong going into your terminal, the question is, where is the rest of the current going? And the answer is, it's going into you, it's going into your finger, and that's what's making up this circuit by touching the end here. Now you're probably wondering why you don't just get a shock when you touch the end here, but I will come on to that a little bit later. The correct way to prove dead is actually using a special proving dead device that most professional electricians will have, but typically not necessary for a DIYer, so that's why I don't own one. But this is what they do look like, and you can see they are a little bit more expensive. The other option you've got is one of these volt pens. So these work on non-contact, and they work by detecting the small magnetic field that's created by a cable, and then they just make a noise or light up. So this one here has a red light on it that comes on when it detects power, and it also makes a noise too. These are very inexpensive, and the benefit is, because they're non-contact, you can also find out if a cable is live without actually having to expose any of the conductors. So really useful and well worth every DIY having. So you can see here, you just turn the volt pen on and got the green light there that it's on, and then hover over, we've got a live current. And if I switch this supply off, you can see it knows it's not live. Then back on, and you very quickly get it going off. So back to how these screwdrivers actually work. So you've got this metal stem that goes all the way up to here, and this is what contacts your live conductor, and then it comes up here, and you can see just about in there, just here, there's a resistor in there, a little bit of wire that attaches to this stem. Then from here there's another little piece of wire that takes you up to your neon bulb here that you can see through here, and then on there's a spring attached to that which goes all the way up to the top to this button on the top. Now what's interesting is it works whether you push this button or not, so as long as you're just touching the button it lights up. And so what's happening is there's mains current coming up here, then this little resistor here is massively reducing the amount of current that can pass through, because that'd be a very high resistance resistor. Then you only need a little bit of current to light up this neon bulb, and then you're completing the circuit by touching the end here, and it's going through you and then to ground, which in principle is fine. But the major problem you've got is this is hollow inside. I don't know if you can see, there's actually a void in there, and the risk is that if anything were to get in here and bypass this resistor, so if anything were to mean that this stem here was joined to the spring up here, so that could be a piece of the spring breaks off and falls down and bridges the resistor, or you get some water in here. That's probably the worst one that would happen. You get some water, some condensation or something like that inside the screwdriver, and that gets down there, bridges that resistor, and then you've got mains coming up here, continuing all the way through into your finger. And so that's the real danger with these things, is that you get a shock, that you get a main shock. Generally anything where you're forming part of the circuit is a very bad tool. I'm pretty surprised these are still okay to use. Something like this, a non-contact voltage tester, is much better, just because there's no contact parts here and you're not forming part of the circuit. And if you're working on a socket circuit, you could also use one of these socket testers. And these again light up and make a noise when they're live. So very cheap and really useful for most DIYers. Now if you've enjoyed this video, please like and subscribe for more, and thanks for watching.